Welcome to Ask and Learn.
Hey guys, let's do problem 17. We need to plot the calibration curve for mass fraction against solution density. We need to do this problem in Excel. However, for illustration, let's see how it looks. So the first point will be in the density 0.988 here, and the second density is around 0.99, and the mass ratio is close to 1. For the second one, 0.992, it is a little bit more than 0.15, and that's how the other 3 points will be at. And we will get a straight line, and the straight line will have this equation: y equal to 545.5x minus 539.03. So here slope is 545.5 and the intercept will be at negative 539.03, and the r square is 0.9992. Therefore the equation for this straight line plot is mass ratio r is equal to 545.5 multiplied to the density negative 539.03. Next we need to estimate the mass flow rate. It is given that the density is 0.994 gram per centimeter cube for isoleucine. Therefore let's calculate what is the mass ratio. Mass ratio will be 545.5 multiplied by 0.994 gram per centimeter cube minus 539.03, which gives us the mass ratio as 3.197 gram of isoleucine by 100 gram of water. Therefore there is 3.197 gram of isoleucine in 100 gram of water, and the mass flow rate therefore is volume flow rate multiplied by density multiplied by the mass ratio. Volume flow rate is given as 150 liter per hour. Let's convert it to centimeter cube. 10 cube centimeter cube divided by 1 liter. The density is 0.994 gram per centimeter cube, and the ratio is 3.197 gram of isoleucine divided by 100 gram of water. Let's get it to kg. 1 kg divided by 1000 gram. Therefore we get the mass flow rate is 4.76 kg isoleucine per hour. Next we need to explain, would the mass flow rate is too high or too low. The mass flow rate that we calculated, if it is too high or too low. Now in this problem we assume that the solution density increases with decrease in temperature. We assume that the solution density increases with decrease in temperature. Therefore the solution density at 47 degrees Celsius is more than 0.994 gram per centimeter cube. Therefore the mass flow rate calculated in part B is too low.